Hello, IB Bio students. So today we are going to continue section 8.1 and we are going to look at rational drug design. So we're going to spend some time looking at this field of bioinformatics. Bioinformatics. And this is the field in biology where databases are used to store all kinds of information. So you can store genome information, you can store proteome information, and through this storage of information, you can potentially develop drugs. So that's why we call this a rational drug design, right? So we can take the genome or the proteome of a particular enzyme, and then we can develop drugs. So this is the field of bioinformatics, and it's a growing field. So let's talk about malaria for a moment. So malaria is a disease that's caused by a parasitic protozoum of the genus Plasmodium. So malaria is caused by a protist, a parasitic protist, and this is the name of the protist. Yet, for the life cycle of this parasite to be fulfilled, this parasite requires both a human and a mosquito host. So, hence, the disease is transmitted via mosquito bites, even though it's not a mosquito that makes you sick, right? It's the Plasmodium that makes you sick, but you require a mosquito host. So, malaria is a very common disease in tropical places in African countries. Here we see a picture of the Anopheles mosquito, which is the mosquito that is going to make you really sick. And if you ever get malaria, you're going to experience fevers, chills, and flu-like symptoms. There are good drugs to prevent and fight malaria, although if you don't have access to these drugs, you could potentially die from malaria. All right, so we're going to talk a little bit about how the Plasmodium uses the mosquito as a host and uses a human as a host to develop. So we're also going to see what happens in that development. So let's look at this picture here for just a moment. So here we see a mosquito, the Anopheles mosquito, and inside this mosquito we have the Plasmodium parasite. Okay, so the mosquito is a host. The human is also a host. So then how does this Plasmodium mature inside the mosquito? Well, a couple things happen inside the mosquito's intestinal tract. So the Plasmodium is going to lay its eggs or gametes. These eggs are going to develop into a zygote. And this is led by enzymes here. This is an enzymatic reaction that not an enzymatic reaction, but the fusion of these gametes that lead to a zygote is enzymatically led. For the zygote to turn into ookinet, also enzymes are required. To turn into an oocyst, enzymes are required. To turn into sporocytes, enzymes are required. I noticed that there's different anti-malarial drugs that are effective to halt this process. So depending on how far along the Plasmodium is in this process of infection, right, there's different drugs that you can take to halt the process. And all of these drugs are in a database, and scientists know exactly how they work. So once the sporocytes are mature, these sporocytes can be transmitted to a human. So that means if the mosquito bites you, then the sporocyte it travels through your blood and it ends up in the human liver. And these sporocytes turn into hypnocytes, and this is an enzymatic reaction, and then into merozoites, and this is another enzymatic reaction, right? And notice that quinidine which is one of the most common anti-malarial drugs, is used to target the life cycle right here at this point. And then it goes from the human liver into the human blood, because eventually when this mosquito or a different mosquito, right, bites you again and it sucks your blood, it is going to uptake these gametocytes and the life cycle will repeat itself again. So what I'm trying to say here is that to complete this life cycle, enzymes are required, right? And then these drugs here and here and here and here are all meant to stop these enzymatic reactions, to halt the production of these gametocytes, to stop this life cycle or process. All right, so let's move up here a little bit and let's look at what scientists are doing. So scientists, they have sequenced the genome of infectious species of the Plasmodium. So we have the genome of the Plasmodium parasite. And we also have the parasite's proteome. So that means that we have the sequence of the proteins. So for the proteome, enzymes involved in this parasitic metabolism, they've been identified, and they've been identified as targets for inhibition. So if I know the proteome of this enzyme here, then I can target it with certain anti-malarial drugs to inhibit the production of the subsequent intermediates. Okay, so these proteomes or these enzymes, they've been screened again a bioinformatic database of chemicals to identify possible enzyme inhibitors. So these possible enzyme inhibitors, what they are drugs, right? That's medicine. So once a promising compound is identified, it can sometimes be chemically modified to lower its toxicity, to improve its binding affinity. And in one particular study, there were over 300,000 chemicals that were screened to identify 19 new chemicals that might function as inhibitors or drugs or medicine. So that's one way to use bioinformatics and database and the proteome of these particular enzymes here to develop drugs. An alternative method by which new drugs or medication for malaria can be synthesized is also known by the term rational drug design. So in rational drug design, in this type of method, you use a computer modeling technique. And in this modeling technique, you're going to invent a compound that you think will function as an inhibitor or drug. So you use what is known as combinatorial chemistry, which means that a compound is synthesized that is complementary to the active site of that target enzyme. So you're going to synthesize a compound that is going to bind to this enzyme, but you've used a computer modeling technique to do so. Just FYI, when the COVID's genome was released, there was also ways in which scientists were looking at rational drug design to look at the genome of COVID, and they tried to use computer modeling techniques also to see if they can find ways to inhibit the enzyme or the virus. Sorry. All right, so that is rational drug design. Also, make sure that you look at these two slides in your PowerPoint. They pretty much go over what I just went over. But it emphasizes what bioinformatics is, right? Is making sure that everything that you find as far as research is concerned, or through multiple research groups, you're able to store that in a database so everyone can share that information and everyone can find medicines and potential drugs to cure different diseases. Bioinformatics has facilitated research into metabolic pathways, and this is also known as chemogenomics. Okay, so that is it for today, and that is it for rational drug design.